just to summarize on what we covered in the last week, I think we looked at what is container, and we looked at how is the container structure will look like, which is, I think, container is nothing but a portable packaging software, which will include the code and runtime and system tools, or the system dependencies. So this is a typical hierarchy structure: infrastructure, operating system, container engine, and then app binaries. And popular container engines are Docker and Containerd, Cryo, Hyper-V, Linux containers. And also we discussed about container versus virtual machine differences, where containers, because of the less overhead, where we don't have guest OS and hypervisor, so it is a thin layer compared to a virtual machine. So because of which it has additional advantages like less overhead, fast boot time, increased portability, isolation, lighter in size, and also the code reusable because all containers are stored as images, which can be reused and cheaper. And also we looked at a lot of container engines that we saw, but I think we zoomed into Docker, which is one of the most popular container engine, and we discussed how this Docker will look like, and which is an open source solution where the Docker will work the same in Linux, Windows, or Mac, and also it works the same way in on-premise cloud and public cloud and private clouds. And we also saw some commands, Docker commands, how we can run a Docker image and how can you pull a Docker image and list the Docker images that are installed on your system. So, and we also looked at how to use a Docker file to create a Docker image, and also we also uploaded that to Docker Hub, which is a repository, a public repository of all the popular Docker images. We also looked at Docker Hub, how it will look like. And also we saw the Docker architecture, which is a client-server architecture. Well, there will be a client which will execute some commands like Docker build, Docker pull, Docker run, and the client call will go to doc host, and host is the Docker daemon that will be running, which will be listening for commands. As and when there's a new command that is available from client, it will check whether the image is already there. If it is not there, it will download it, and from the image it will create a container. So then these are the high-level structures that we saw. And Docker registry is Docker Hub is a public registry, but it is not required to host in Docker registry, Docker Hub. We can also have your own private repositories of container images also. Generally, enterprise where they use a private registry, not public registries. So that's about the Docker architecture. And yeah, so with that, I think we understood it is easy. We also saw a lot of commands. Also, we executed a lot of commands the last session, like how can you create a, we also how to simple Alpine image we downloaded, and then we ran the commands using Alpine, and also a somewhat bit complex, where we also deployed a web application, a Python-based Flask application, which is exposed on some port, and how to expose a port inside Docker. So we saw all those commands also. As extension, so yeah, Docker is good for most of the smaller use cases, but when you take a real-time use case, there'll be multiple services which they run, and each service could be a small Docker image. Yeah, for example, take an e-commerce application. Take your orders could be one microservice. Your shopping cart could be one microservice. So likewise, there will be a lot of modules within a project, and each module could be a microservice, and it will have its own Docker image. So just for one e-commerce application, that could be at least minimum more than one microservice. So more than one Docker images will be there, and also there will be dependencies between the Docker images also. So how will you handle that? So suddenly that part of managing a flow within Docker image, when there are multiple Docker images, how will you manage that? So that has become a complex part. I mean, it is okay to manage one or two applications, but it is not. It will be difficult to manage if there are many Docker images. So that's where you need a tool which will help you to orchestrate the Docker images or container images. So that is where you need an orchestration tool. That's where Kubernetes is one of the orchestration tool, container orchestration tools. So as I said, like Docker is good, but but these are the following problems that Docker has or Docker doesn't solve. The problem statements are there are, let's say there are multiple microservices. I think we just discussed one like Amazon or e-commerce application. If you take, there will be multiple microservices and there will be libraries for each application. So and each one is in one container. So how do you manage multiple microservices and deploy them independently? So how will you manage that? So that is one problem statement Docker doesn't solve. So Docker will give you any container image, but first this microservice, then this microservice, or this microservice requests this set of libraries, other microservice needs this set of libraries, and you have such dependencies, then it suddenly becomes complex. So Docker doesn't solve that problem. And also, how do you coordinate the containers? As I said, like there are multiple containers are there, multiple Docker images are there. How will you coordinate? This one should be executed first, then this should be deployed next, and this should be deployed next. So how will you coordinate the flow within the container images? Docker doesn't solve the problem. And how will you schedule the container deployments? So if you have a scheduling requirement, then how will you schedule it? So again, Docker doesn't solve that. So how to seamlessly upgrade an application without any interruption of services? This is very common because typically in a microservices world, each microservices are independent. So most probably if there is a development or feature that was introduced in shopping cart, you just need to deploy the shopping cart. But at the same time, it should not interrupt other services which are running. So in that case, how will you seamlessly upgrade an application without interrupting the services? Then how to monitor the health of the application. So again, Docker doesn't give any ready-made tools for you. I'm talking as a Docker engine. Docker engine doesn't give you any tools to monitor the health of your application. It doesn't check whether your application is down. Then what should I do? So it doesn't solve that problem. You have to take care. And how to restart when something goes down or something goes wrong. How will it monitor that something goes down? So all this are the operational problems that you have, which Docker doesn't solve. Um, so and when you have so many microservices, this is a day two problem for you. When you're going live, you need to manage this. Once you're gone live, the second day of your go live, you should manage all these problems in production. So that's where you need a tool which sits above this Docker or containers and manage these flows and solve all these problems that we discussed. So that's where a container orchestration tool is the solution, which will help you to automate the deployment, scaling, and also managing your containerized applications on a group of servers. So, and if you look at it, a group of servers is a keyword. I mean, generally you deploy in one machine, it is okay, it is simple. But when you have to deploy this in multiple machines, because you need multiple machines, because if something goes, one machine goes on, other machine should still serve the traffic. So this containers have to be deployed in multiple or group of servers, not just one server. So all these things are a complex problem to solve, and that is where this container orchestration tool will help you to address all these issues. And the options that are available in container orchestration tools that are available in the market are Kubernetes. Kubernetes is not the only container orchestration tool. We have other tools like Docker Swarm and Apache Mesos Marathon. So these are the other popular alternatives apart from Kubernetes. But of course, Kubernetes has become almost a de facto standard now. But still, there are people there is a large community still use Docker Swarm and Apache Mesos. But Kubernetes is kind of getting stabilized, and and more interest is towards Kubernetes and everyone moving towards Kubernetes. So that's why it's become so popular because of a lot of advantages that it has. So yeah, so now we understood why we need a Kubernetes or a container orchestration tool, because it is solving a lot of problems which Docker doesn't solve. Right? So it is easy to manage one or two or three or into one machine is okay, but when you have to do this for a wider set of machines or more machines, then also to manage all this coordination, scheduling, upgrade, seamless upgrade, monitoring of the health and restart, all these problems are not solved in Docker. So that's where you need something, a tool above, which is container orchestration tool. And Kubernetes is one popular one. So with that, let's go to Kubernetes. What is Kubernetes? So as I already mentioned, Kubernetes is a container management orchestration tool. So it is a completely open source solution, which is primarily for automatic deployment, scaling, and management of containerized applications. So when I say automatic deployment, I will show you a demo where you will see all these things, where you can just tell uh, how many instances you need and where to deploy. So it will automatically deploy it, and it can automatically scale to the number of instances that you need. So and also it will solve all this workflows and other containerized management problems are all solved. So that's where this Kubernetes will help you. Basically, if you just give the background, Kubernetes actually is developed by Google and was later donated to CNCF. CNCF is like any other open source foundations like Linux Foundation or Apache Foundation. This Cloud Native Computing Foundation. So this is a consortium where it maintains all the open source projects, especially related to cloud native implementations. So yeah, so again, since it's developed by Google, it has all the lessons learned by Google in the last 10 years using this software, and they addressed all the problems, all their day-to-day applications were all most of them are now completely containerized, and they are using Kubernetes equivalent, which is a Borg. Borg is the old project before Kubernetes came. Google had a project called Borg. Borg is an older version of Kubernetes, and still it is running. It is used in Google still, and basically Kubernetes is inspired from the internal Google's internal project called Borg. So if in fact if you look at the YouTube mails, Google Mail is all completely on Kubernetes. The older version of Kubernetes is Borg, so it is most of them are still running on Borg or Kubernetes. Borg is just to give the background. Borg is monolithic, not microservices based architecture, and it is 10 years old. So, but I think Kubernetes is completely developed from scratch, taking all the lessons learned from Borg, and it was completely developed from scratch, and it is developed in a language called Golang. So, this Kubernetes is completely developed on Golang. And a very important aspect is that it follows Kubernetes follows a declarative approach. Means YAML files. I don't know whether you've seen YAML file, heard of it, but these are all. I mean, it's similar to a JSON file. So YAML has a convention to be followed, and so I will show you an example of how a YAML file will look like for not seen before. So it has some conventions to follow and follows a declarative approach. Meaning, when I say declarative, it means you need to declare your intent, saying that I need this many instances of or my containers that should be running. So you should tell how many instances you need. Basically, it is giving the requirement. So if you give the requirement of your deployment in a YAML file, Kubernetes will ensure that your requirement is always met. So So you need to take care of the burden of how many instances you need to manage. If you just need to tell the requirement in form of YAML, um, uh, then Kubernetes will ensure that your requirement is solved or met. So yeah, and another thing, Kubernetes is also called as K8s. K8s is Kubernetes. I mean, K in K and S there are 8 characters. That's why it's K8s. So I mean, it's also popular. I mean, many people call us K8s because the name is very big. So yeah, and the logo, if you see, this is the logo of a Kubernetes, which is like a healthspan. Healthspan is is the one which guides a ship or a boat. So, for example, if you see a ship, the pilot will steer the direction of the ship by rotating this left or right. So the same concept that was taken to steer a ship is like steer a container in our case. So so that is the meaning of this purpose of this logo, and of course you can create this Kubernetes on your own on-premise environment, which is completely open source. You can set up this Kubernetes on your local environment. Of course, but again, you have to manage many things. But if you are looking for a managed services by cloud vendors, so all the popular cloud vendors, offer this Kubernetes services. I just listed three because these are three popular ones, but there are other vendors who also support Kubernetes. But this is all from popular public clouds. Azure, it is Azure's Kubernetes service is called Azure Kubernetes Service (AKS). AWS is Amazon Elastic Kubernetes Services (EKS), and Google it is Google's Kubernetes Engine, so GKE. So for this demo, we will be looking at Google Kubernetes Engine, but the concept that we are looking at is completely open source, which means if you understand this concept, the concept will remain the same whether you go to Azure or AWS or Google or even your own on-premise setup. The concepts will remain the same. We completely ensure that we look at we understand the open source version of Kubernetes. Of course, cloud vendors will have some additional, not very minimal, but there will be some additional features which will be specific to cloud. But I think this sessions that we are looking at will be completely focused on open source solution what Kubernetes offers, and so that the concepts will remain the same whether you go to any cloud for that matter. But for the demo purposes and other things, we will use Google's Kubernetes, but the concepts remain the same wherever you go. Any questions here? Okay, so this one of the things is Golang is one of the popular programming language, which has become super popular just because Kubernetes was developed, and Go is introduced by again Google. So Golang is more of a system programming language, but has many advantages, like similar to C programming or C++ programming, but it has a lot of advantages compared to the system programming. But of course, it was initially came as system programming, but eventually it also ended into a full-fledged programming where it can also where you can also develop a web applications also like just like a Python or a Java or .NET. So it has extended. So the summary is it has features of both system programming and also the web programming. So so yeah, just sort of sharing you that knowledge on Golang. In fact, completely the all the modules within Kubernetes are mostly developed on Golang. Okay, let's look at. So we understood what is Kubernetes, because we have not gone into the details, which I will give a demo so you'll understand this better. But so at least we have an idea of what Kubernetes is solving the problem, where it is solving all the problems of automatic deployment, scaling, and management of containerized applications. That is what Kubernetes is for, and it's primarily a container management orchestration tool. Um, so again, what is Kubernetes? We understood. Then why also is a very important question to answer. So why we need a Kubernetes, right? So the Kubernetes, if you look at why, so it solves many problems which in day-to-day that you need to deal with. One is the easier management and discovery. So if you look at there'll be a lot of containers. Generally, they make a one microservice or a service. Take the e-commerce case, there will be multiple microservices. It will and you need to deal with a lot of containers. And it logically groups. By Kubernetes will group all these containers together. It will make an application. So and also it is easy management and discovery. So and also it builds on 15 years of experience of running production workloads at Google and also the best practices from the community. So all this together is what is Kubernetes is. So it is completely an open source solution, and it is already proved and tested in Google and with 15 years of experience of running in the form of Borg. So all the plus and minus points are all covered in this Kubernetes. So if you look at this diagram, so if you look at the small boxes here, these are all various applications that you need to manage and to group them together. So it is easier to manage them. And whenever you want to deploy your applications to nodes, nodes are nothing but virtual machines or VMs. So whenever you need to deploy your applications to nodes, Kubernetes will help you to easily manage, discover, and also it will deploy your applications onto the nodes. Um, and if you go further, it is also planet scale. Scaling is very important aspect because when you say scale, there will be always a limit for a scaling. But yeah, again, here it's called planet scale because which means you can run billions of containers, and it is already proved and tested. Because Google is already using this application for almost last 15 years, so it has designed all the same principles that Google follows to run billions of containers a week. Generally, I mean, this Google's. I mean, we know how many people who use YouTube or Google search or Maps. These are all built on as container images, and Google generally runs billions of container images because it need to scale to that much level because Google products are being used worldwide. So when you have to manage such a traffic, so you need some very robust system which can handle that scale. So that's where Google Kubernetes is built on the same principles, and it can manage such a huge load because the enterprise that we work or it if you are solving a Google's scale. Google has set a benchmark for a scale, right? So Google used worldwide, and it has set a benchmark. Is one of the top products that will get so much of traffic. So yeah, if such a scale applications can be deployed on Kubernetes, even even our applications within our enterprises, even though they may not get that scale, but of the traffic, but still, if that is set a benchmark. So Google's benchmark is set so that we can also use the same for our own purposes. So and also it can scale to without increasing your operations team. That is a very important keyword because when you have to scale, it is when you have to scale for if it is 3, it is okay. 10, okay. If it is millions, then you also need to increase your operations team also. But with Kubernetes, it primarily solves all your operations team's problems, and it doesn't require you to increase your operations team. Of course, you need to increase your teams. I don't say it not say that you need to increase because, but it helps you to at least optimize your operations team. So you need to increase because many of the problems Kubernetes already solves for an operation person. So it is more popular, and also never outgrow, which means the Kubernetes flexibility grows with your organization. So you can start with simple, and it can go to a complex requirement also. So basically, it's kind of a one one tool which will support um, simple to complex needs. So that is what this Kubernetes, because I mean the small startups can use where you're expecting load within a region or a country, that's okay. But if you're a bigger organization, even same Kubernetes can solve your complex needs also. If you're a global company, then you're a complex system. So even Kubernetes can solve that. So basically, it can solve from simple needs to complex needs. So you need to change your tool when your traffic or when you're going big, when your organization is growing big. Again, run Kubernetes anywhere. So this is the highlight of Kubernetes, which none of the other tools solved this problem. Kubernetes is completely open source, so and it can run the same way on on-premise, hybrid, and public cloud infrastructure. So, and also it lets you to move your workloads effortlessly to wherever you want. So once you develop your container image and once you make your application working in one Kubernetes environment, probably your on-premise or maybe in Azure, today, tomorrow, if you want to change to some other environment, probably Google or AWS, can just effortlessly move your things easily to cloud, go to other vendors cloud. So because it is cloud native, so that's why it's called cloud native architecture. So cloud native means irrespective of whatever cloud you're using, if you're using Kubernetes, the promise is that your changes or migration path will be simpler. So that's what the CNCF or the Cloud Native Computation, the CNCF board, all the tools that CNCF operates is all under the category of Cloud Native, which means any tools under this umbrella will help you to migrate to any cloud or on-premise easily. I would say easily. I wouldn't say it is smooth. Sometimes it could be there will be difficulties, but I think it's just it actually minimizes the effort as much as possible. Okay, any questions in this? Why Kubernetes? Okay, let's move on. Let me know in case if you have any questions anytime. Please stop me. Okay, then let's look at what are the features of Kubernetes. So I think we discussed most of the important features already, but I think just to summarize, um, this features primarily solves the problem of auto scaling and also service discovery. We look at all these features in detail, but I think it just to understand what are the features that Kubernetes offers. Service discovery and you all know what is auto scaling, but service discovery is a feature where, especially when it comes into microservices, you need to understand there will be a lot of services that will be deployed. So in that case, you need to know which service to call at any given time. So the service discovery is one of the tools which will help you to identify which services are available in the system. So Kubernetes gives that feature of discovering the various services within which are deployed in Kubernetes. So that is what a service discovery is. Then load balancing is most of the stuff is very obvious. So you have to manage the load when the load there is spike ups. You should manage when there's a demand, it should spike up. Also, when there is no demand or less demand, it should spike down. So load balancing will help you to balance the load based on demand. And Kubernetes is a one of the best feature in this Kubernetes is to manage this load balancing. And also self-healing. Self-healing is this is a very unique feature in Kubernetes where uh, I mean we, these are all the features that we know already. This is all good when everything goes good, meaning auto scaling. Okay, when there is a demand, it increases, the load manages the load. But what happens if something goes down? Um, so something goes down, then Kubernetes can detect that something has gone down, and it will automatically self-heal itself. So, and it can automatically discover that something is down, and it can recover from the failure. So that is what a self-healing is. Um, then automated rollouts and rollbacks. This is very common. From our experience in IT, we generally deploy our projects to production, and always every production deployment, if it goes good, it is good, but always there's no guarantee. But sometimes if something goes down, you should roll back. So something you deployed and something doesn't work, then you need to switch back to the older version, right? So in production deployment. So again, before Kubernetes, it's all manual deployment of your libraries and roll back to the previous version. So all that is completely automated with just one command. So that is the beauty of this Kubernetes. So it can, with one command, you can um, roll out or deploy something new, and also roll back if something is not good. So, and service topology. So again, you can come back to the microservices. Is the most better fit uh, for microservices, but again, it doesn't mean that it's only for microservices. It can support even monolithic also. Only prerequisite is that Kubernetes will expect your application to be containerized. Um, Even a monolithic application also can be deployed on Kubernetes, but it has to be containerized. That is a prerequisite. So again, come back to service topology. So you can see the complete dependency of services, and completely Kubernetes manages your services. Meaning, let's say yours is a three-tier architecture. You have a front end, you have a middleware, and you have a back end, your database. So and you have a flow that first you need to deploy your front end, then probably first you need to deploy your back end first, which includes a database and API components. Then your front end comes into picture. Probably any other dependency projects also will come in. So if you have such hierarchy of services, so Kubernetes will completely efficiently manage that topology. So that is the beauty of one of the beauty of Kubernetes, where whereas you need to maintain this on your own, which will be very manual. So, and again, similar is storage orchestration. So I think so far we discussed about containers and orchestrating the containers, but this containers also require a storage. So, for example, all your logs will require some storage. So it also manages the storage. Kubernetes also manages storage very well. So the once we go into the application, we'll understand. So, for example, every Docker image that you're pulling, for example, you created a Java application and then you deployed it, and this Java application is writing a lot of logs. So these logs have to be stored somewhere, right? So you need a storage. Similarly, you have database, and your database also requires a storage, a persistent storage. Um, so that's why it is important to manage the storage. And from the last sessions, from the past sessions, we also know that storage is a lot of various variations in storage, like file storage, block storage. So we have a lot of variations in this. So Kubernetes will manage all the storage aspects for you, irrespective of whether you need a file storage, SSD or HDD, or you have a IO intensive application, then you need a lot of IOs. Or if you need a block storage, then EBS or in AWS. So similar to that, we can have block storage, and you can also use the S3 equivalents also, so object storage. So a lot of variations that you can have in storage, and Kubernetes will efficiently manage various storage aspects. So, and next is secrets. Secrets and config management. This is most of our applications, all the passwords, for example, have to be maintained in secrets. For example, your DB password or your application passwords. Or your tokens, API tokens. These are all secrets that you need to manage. And if you imagine that you are outside Kubernetes, then you need to use some vaults or any other vault-based solutions to manage your secrets. But Kubernetes has an inbuilt vault equivalent which can manage your secrets and also your configs. Configs is like you have to maintain a lot of configuration. For example, your properties file is a config where you have key value pair, like environmental variables you need to manage. Those are all configuration. So config maps is one such feature in where you can store all your configs inside. I mean, you don't want to keep it inside your application, but you want to externalize it in terms of properties files. Then you can maintain all the configurations inside Kubernetes. And the next is automatic bin packing. Bin packing is your binary deployments. So creating your binaries from your application, whether it's Java or .NET or any other Python. So it can manage your packaging of the software using, again, it internally uses Docker. So it creates a container image and pushes to, I mean, the prerequisite is that container image should be available. So that is a prerequisite. So container images generally will be available assuming that container image is available in Docker Hub or any other equivalents of Docker Hub. It can automatically pull that image from using Docker pull equivalent, and then it will package your software and then deploy it. Then batch execution. This is a recent addition, the last two in fact. The batch execution is I mean, almost, it's from the name itself, it's a batch. I mean, most of the applications this is all one-time deployment. It is good, simple, manage. But imagine a batch, which means you need to deploy multiple things in form of batches. So it's a recent addition that was introduced where you can deploy all execution of all your components in form of batches, and it can be deployed as a bunch. For example, overnight you can deploy all your deployments, multiple container images in form of batches. So that way, when you come the other day morning, you have everything deployed. So especially you have such a big load. I'm talking about this is primarily useful when you have thousands of microservices which are to be deployed. So then you can execute in form of batch. So that way it handles very effectively. And also this also all our applications need not be it be even standalone application. I mean, all deployments need not be a web application. There will be standalone applications also. So even standalone applications also can be deployed via batch, and we can schedule the batches at what time this deployment should happen. So all those features are all available in Kubernetes, and which is IPv4, IPv6, which is primarily networking stack. So you can allocate the IP addresses for your deployments. So it can allocate IPv4, which is what generally we use 10.1.1.2, for example. It's a popular IPv4 stack. But as we all know, that IPv4 is coming to an end very soon, and that's why recent edition is IPv6, where you get a more bigger IP range. Which is now becoming more or less popular with all clouds, because IPv4 has a restriction. Very soon IPv4s will end. So you need to go for a bigger IPs. So IPv6 was a new entry, and luckily Kubernetes supports IPv6 also. So I have both IPv4 and IPv6 support available for Kubernetes. Yes, so that's features. I think probably some of them would be overwhelming, but we will go through these features in the demo so that you understand this better. Any questions here? Okay, so imagine this Kubernetes. Without Kubernetes, if you go out, like if you were to do this all these things, you have before Kubernetes, all these problems are somewhat solved. But if you look at from the cloud knowledge that we have so far, uh, um, uh, before Kubernetes, we have separate tools for each of this. If you imagine for scaling, we have so for irrespective of what are with the cloud, we have scaling related products, then load balancing related products. Self-healing was not there at all. And automated rollouts and rollbacks, you have to manage with some scripts through Jenkins or any other management software. The service topology you need to manage. Storage orchestration is there. The secrets and all, you need to use vaults or anything. So bin packaging, it is not automatic. You need to write your code. Batch execution, you need to use AWS batch or Azure batch. So IPv4 is again, you need to use separate networking products. So all these features were already there, but you need to use so many independent products within cloud or even on premise. You need to manage all these things with separate products. But if you see here, whatever whatever an application needs, all these features are clubbed into one product, which is Kubernetes. Okay, so with if you understand Kubernetes, what are common problems that we need? We need to learn so many products separately. Just one product which can solve all these problems for you. So that's why it becomes so popular. So you need to go for a load balancer because Azure or AWS, Kubernetes, they internally use the load balancer tools, but you need to know about the inners of how those load balancer tools are used in Azure or AWS. You just need to know how to create a load balancer requirement in form of YAML, and in Kubernetes way of handling. You just need to know how to do that. Behind the scenes, it will call the respective tools which you don't need to know at all. So that is the beauty of Kubernetes. So apart from the popular products, which are behind the scenes, but it also adds a lot of important features like self-healing, which is very important because if something goes down, it should automatically detect and tell you that something is down. So this is a very important feature in production. Then automated rollouts and rollbacks. Rollouts is okay. Rollbacks is it should be very quick. When something goes down, when you deploy something, and you should roll back. If you find some issues, then you have to roll back immediately. In most organizations, it will take 1 or 2 hours to roll back. But it is here in Kubernetes, it's just a one command line which will roll back your code, which is pretty quick. Um, and also the orchestration of various storage aspects. You need to worry about secrets. Everything is managed within Kubernetes, and batch execution and networking aspects. Everything is managed. So basically, summary is like all in one, like one product. You have everything in it. So that is why it's become so popular. Uh, so yeah, so let's move on. Any questions here before we move on? Okay, so let's look at demo now. So I mean, so far what we saw here, this we can realize what is the command, one-line commands that I was referring. So everything is CLI driven mostly. So CLI is like all our command lines. So with one command, you can execute most of it. So in this quick demo, what we're going to do is I'm going to use GCP. GCP is like Google's product, Kubernetes and GCP, which is GKE, Google's Kubernetes Engine. So we will create a Kubernetes cluster in GKE, and basically what the steps would be to what I will do is I will deploy a web application, a simple hello world application. I mean, for the sake of this, I took last time I showed you Python. This time I'm planning to show you a Java application. It is, I think, simple application, hello world application. So this application will be deployed to Kubernetes on GCP. At this process, I will basically log into GCP, create a Kubernetes cluster. That's a prerequisite with 3 nodes. Uh, a cluster is a very important concept that you need to know. From the name cluster, cluster is like group of something, right? So it's a cluster is group. So here, what is that group? Group of nodes. So basically here, what I will do in this demo is I will create a cluster, and in this cluster I will create 3 nodes, 3 node cluster, which means 3 virtual machines will be clubbed into one cluster. Probably to show you a quick, yeah, this is what you can imagine that this is a 3 node cluster. Each node is one VM. So basically VM1, VM2, VM3. So I'm going to create 3 VMs. Um, so and I'll create all these 3 nodes as one cluster, and in this process, the cluster will have something called master node, which will manage the cluster, and worker nodes, which will run your application. Yeah. So once I will show you, you'll understand it. So basically, it's when I say 3 node, 3 VMs will be created. Out of 3 VMs, one will become as a master, and other 2 will become as worker nodes. Probably once I explain the architecture of Kubernetes, you'll understand what is master node and worker node. But you can imagine for now, there will be a master in Kubernetes who will ensure that your cluster, which is like having 3 nodes, so all the cluster is working fine. That is the role of the master. And worker nodes will get the instructions from master, and basically this worker nodes is where your application is actually deployed. So once you go into the architecture, you'll understand that better. But yeah, for now, let's quickly jump to the demo. So what I will do is I will connect to GCP. Probably if you're seeing this is the Google platform.
Yeah, Sham.
Yep.
So just to give a background, that this master or controller with the worker node architecture was there in many of the, for example, data warehousing, Redshift architecture. In one of those, even blockchain, when they introduce things, this was one of the architecture. So this architecture, master slave architecture, is there for very long time. But what made it different is they took the master slave architecture to the raw compute now. That is what Kubernetes. So this master slave architecture, whatever has been in other places, they just generalize it so that now they could able to basically abstract things around, and they get uh, the real raw compute power out of it. So this is, say for example, Google is having this internally for last 15 years. And one of the reason they are trying to open source it and popularize it is they want to the with the two of the technology. One is Kubernetes, another is TensorFlow. So this is their real, if you see the cornerstone, and why they are trying to make it open source, and why they make it everybody gets access to it and so on, right? So they could have kept it secret and they could have come out with more services. But the reason is the cloud. They AWS is so prominent in cloud, and Azure has captured. So these guys came little late in the game, and they figured it out. One of the way to capture the market share is get this raw compute to the uh, general audience, and it is a perfect timing also because of the containerization. Once the containerization was there internally by them, initially Google was using, at that time the Docker wasn't there that prominent. So Kubernetes will work not just Docker, with across with other things as well. So they had a proprietary Dockerized thing within Google first, but once Docker took into the popularity, it works very well with the Docker. Yeah, I think that the ecosystem is kind of the master slave architecture has been taken to the raw compute power is what the power of the Kubernetes. Yeah, just thought of you. Yeah, go ahead.
Yeah. Okay, so this is I'm going to create a Kubernetes GKE. I'm going to use Google Cloud Platform. I think I've not introduced to Google Cloud before. I think yeah, this is you need to connect to cloud.google.com, console.cloud.google.com, which will take you to the Google dashboard. Probably I'll come to home page. This is how a home page will look like. So generally, this GCP has sort of similar, like just like any other cloud, like Azure or AWS. We have a lot of products within GCP, which we already saw in our earlier sessions. So it has various products starting from building to support, security, compliance, compute, uh, storage, databases, networking, operations, which are monitoring, a lot of tools around allowed developer tools and big data, AI. Yeah, so like a lot of tools or partner solutions from outside other enterprises, which has like Google's partners. Their products are also it's kind of marketplace. So yeah, so all these various products are there. I think we'll go into this later, but I think since we are interested in Kubernetes, so we'll go to Kubernetes Engine. So here, if you go to, you can see this Kubernetes also here in this compute because it comes under compute aspect. So compute engine is like a VM, and Kubernetes engine is your Kubernetes solution equivalent. So you can, yeah, I'm just going here, going inside GKE. So the first thing, as Srini mentioned, we need to create a cluster, which means you need to you should form 3 nodes minimum, so that if one node goes down, still other nodes are still active. So that will ensure that your scalability is met. Not just scalability, also your redundancy or the downtime can be minimized. So I'm going to create a cluster. So which is part of this cluster. When I create, I get 2 options in GCP. One is standard. Autopilot is very new addition, which was introduced, in fact, like less than 1 month back. This autopilot was introduced. But yeah, I will not look at this autopilot. We'll go to standard.
So what is the autopilot?
Autopilot is a feature which will, even if you go to Kubernetes, you need to manage many things on your own. Even though it is managed services, there are a lot of inputs that you need to provide. Uh, but the advantage here is that you'll get a complete control here on the worker nodes. But even the problem is, even this is also a bigger problem to manage because so many things that you need to know about Kubernetes. And especially for a starter who's just starting into Kubernetes, you need to remember many things. You need to know various knobs within Kubernetes and architecture and how it works. But Autopilot will will look at the concept of we will automate standardize many things. You don't need to know many things because Google will create all the clusters with all the defaults so that your input is very less. So that and especially it will help you when you are not very experienced Kubernetes developer or Kubernetes administrator, especially Kubernetes administrator. If you're not an experienced Kubernetes administrator, this will be a good starting point because it takes care of security, it takes care of your nodes, and if something goes down, what are the replicas that you need to manage. All the default standard configuration is all managed within Autopilot. So that way,
Yeah. So this is one of the key thing. Like for example, AWS as a EKS, Azure as a AKS. It's Azure Kubernetes Service, Elastic Kubernetes Service. This is GKE, right? I think since these guys have the real knowledge because it came from them. so the enterprises, the way they are positioning is they are either going with AWS or Azure as the primary cloud, but as the Google as the secondary cloud, because they don't want to keep locked in one cloud, and they try to spread using the Kubernetes across. That is the trend going forward. Yeah. And from learning perspective, also GKE with Kubernetes is a little easier than the other things.
Yeah, I think I mean, looking at the innovation happening in this Kubernetes space, I mean, looking at other cloud vendors, I think at least in the Kubernetes space, Google Cloud is leading. Even if you look at, they are the first people to roll out anything to production. Whenever Kubernetes as open source solution comes with a newer version, so generally there is a competition between various cloud vendors who will bring the latest into their cloud. So always GKE, it is Google Cloud leads in that because yeah, it has that advantage of knowing the features and concepts well because of their experience. Yeah, and this autopilot feature is a new feature which is not there in other other clouds yet. So this is very interesting feature. Especially this will help you when you're not an experienced Kubernetes cluster administrator. I mean, this is I mean, Kubernetes has two flavors. One is as a you can position yourself either as a Kubernetes administrator or you can position yourself as a Kubernetes developer. So that's why even the certifications are also categorized based on that. Kubernetes administrator, who is primarily an operations team, will be coming into that space. But if you're a developer, an architect, so you should be coming into the Kubernetes developer role. And but I think the toughest part is the administrator, meaning from developer angle, you just need to your infrastructure will be managed by the operations team. You just need to deploy your application. That is the easier part. But for the infrastructure person, like operations team, he has to manage the cluster. Cluster will have a lot of nodes, and you need to ensure that your infrastructure is not going down at any given time. So managing that infrastructure or administrator is the toughest job. And it has many people burn their hands because once Kubernetes has a lot of things to learn. The learning curve is steep, so you need to learn many things because it is multiple products put into one bucket. So you need to know about networking, you need to know about storage, you need to know about compute, and how will you ensure the scaling, replication. So a lot of things to learn from this. So administrator is a tougher job. So to automate or bring many people into Kubernetes, this autopilot board will ensure that many things are defaulted with the Google's knowledge. Like it brings an optimized, that's a keyword, optimized Kubernetes cluster with the hands-off experience. So many things are defaulted in the administrator side, which will make the life of an administrator a bit easier because it takes care of scaling based on the workload. Here you need to configure the scaling. And the nodes, if you look at nodes, are the VMs that we're talking about. Google manages and configures your nodes. It ensures that all your nodes are updated with the latest OS and patches. But here you need to even though it is a managed service, you need to manage and configure your nodes. And also the configuration, so it's streamlined configuration, ready to use, like handmade ready-made templates that you can reuse. But here you need to give a lot of inputs for that. So yeah, a lot of features around that. So I'm not going to the detail of what is autopilot, but we'll take some other day. But I think for now, let's understand the hard way. Let's go create a standard mode, and then we'll come back to autopilot and see how many things are defaulted in autopilot. Yeah, so let's go to this create cluster. I'm selecting a standard configure. So at this point, first thing is I want to create a cluster. So this cluster creation, when I create a cluster, I'm giving inputs in terms of what is my cluster name. So it could be anything, your project name or anything for that matter. So I'm just retaining the default cluster one. Here you can have an option to select whether it is a zonal or a regional. The difference is zonal is within your zone, but if you're an international organization or a bigger company, then it is good to have regional, so that if one node goes down, the nodes or the VMs that were created in a cluster, they'll be geographically separated. So they all will not be in one zone. They'll be spread like out of the three nodes that we create in this cluster. Each node will be in a different region. So that way, if any disaster happens in a particular region, still other regions are still safer. So that is the advantage of regional, but again, it comes with a cost. So I'm keeping it zonal for the demo purposes. Here you can select out of zones that are available. Again, I'm selecting it. Again, it's nothing but regions across the world. So like North America, South Asia. So I'm just selecting US Central 1A. So here this comes. What is the release of the Kubernetes that you're interested? So either you can go for static version of Kubernetes, which is the latest version is this 1.17.15. So of course 118 is also there, but again this is very new. But this is a default that is given. So of course you can also select the latest one if you want, if you're interested. So I'm going with the default value. And let's say I'm just creating it. So if you look at before creating it, I can look at this command line, which will tell me is my screen still shared, or could see my screen?
No, sure. No,
Okay.
I'm not able to see your screen.
Yeah, I got a message saying my screen got disconnected. I don't know why it happens.
Yeah, suddenly it went off.
You could see my screen?
Yeah.
Okay.
Yes.
Okay. Yeah, so here also you have a command line option. Where of course, you can also ensure that you can also create the steps in a REST way also. This command line will give you the command. Of course, this is a CLI command. Everything the CLI way of calling it. If you're not interested, do it from a UI. If you're more a command line guy, so then you can execute this command also. So so this will create a cluster for your Kubernetes cluster, gcloud command. So yeah, just for you to understand. So I'm just creating a cluster now. So what I think this cluster creation at this point, what it does is it creates. It doesn't say how many nodes, because by default 3 is the default node. So basically, to create three. Three virtual machines behind the scenes, and it will form them as cluster. So so if you look at here, you can also see here it is something that this cluster creation will take some time, because it has to create three virtual machines behind the scenes, and it should all create all these three virtual machines comes along with their networking, with their storage. So all these things will at least take a couple of minutes. So I think in the meanwhile, let's go back to the presentation and then come back once it is ready. Yeah, so before going into this, whatever it's creating, so let's understand what are some terminologies within Kubernetes. So what we use the term cluster. Cluster, what is cluster? Cluster is nothing but a group of nodes. So by default, you can create three nodes. Node is nothing but a virtual machine. That's where you run your application. So cluster is a group of nodes. You can create three virtual machines together and form a cluster, or you can create n number of nodes and form a cluster. It's up to you. And nodes is, as I said, like this is where your node is nothing but a VM. That's where your application will be deployed, and Kubernetes will deploy your application nodes. And the node is container. Container we also saw. Docker is one container engine, but it's nothing. What is container? Container is nothing but a unit of packing. It's a package software. So yeah, if you look at we saw a lot of container packages available in Docker Hub, where we did Docker pull and the container image got downloaded. So it's nothing but a package software. And what is pod? pod is nothing but it's a unit of deployment. Again, this terminology within Kubernetes. When it's a unit of deployment, this is the smallest unit of deployment in Kubernetes. When something is getting deployed in these nodes, what is getting deployed? It is pods. So pods will be deployed on the nodes. So when you're creating three nodes, your pods will be deployed on those three nodes. And this pod is what is pod will have containers inside. For example, one pod can have one container, or it can have more than one container also. So the smallest unit in Kubernetes is pods. So it will pod again is bigger than container because one pod can have multiple containers. For example, I'm just giving an example. So let's say your web application. So you have front end and back end. So you have two containers. One is front end developed in Angular or React, on the back end, which is developed in Java or .NET. So you have two container images, one for front end, one for back end, and there will be one more container image for your database. So take a simple web application. You have three containers. It is possible that you can keep all the three containers in one pod. It is possible, but it's not a good practice to do that. But you can club all three containers into one pod, and it can form a smallest unit of deployment. But it is again, good practice is to minimize as much as possible. Mixing of multiple containers into one pod. It is good to minimize as much as possible. But it doesn't. Yeah, it makes sense in some cases, but not in all cases. But yeah, what you need to know is pod is your unit of deployment. When someone says why my application is not working, because your pod is not running on the node, or the pod is died, or you might have pod is stopped. So these are various cases where your application is not running. Okay, next is these are some terminologies that you will understand. Where the first time it will be very new. It also took for me to understand all these concepts, but again, these are all terminologies within Kubernetes. So first time it may not be new, but I think once you go in detail, you will understand and you will become familiarized. Replication controller. From the name itself, it is a replication controller, which means it will ensure that your availability and scalability requirements are met. So, especially your desired state. In Kubernetes, you need to tell what is your desired state. And it's nothing but your requirement. In the form of YAML, you need to tell what is your desired state. Let's say your desired state is I want this Java application to be running 3 instances on and each instance should be in a different node. That is your requirement. Then you should tell that this is my desired state, and replication controller will ensure that that availability and scalability requirements are met. So that's how it populates, replicates your pod in all the nodes such that your availability and scalability requirements are met. That is what is a replication controller. And labels. Labels are nothing but key value pairs. You can use labels. For example, labels could be your metadata for your application, for your pod. So you can tell these pods, you can label this as production pods. Production could be one label, development and testing could be one label, or you can say project A, project B, project C could be one label. So likewise, it's just a key value pair to identify the pods. So it's just a metadata information. So and next is services. Services is it's nothing but this pods will it can die down. I said like pods can, just like a Docker images, right? Pods is nothing but a collection of Docker images or container images. So these pods can die down. They're ephemeral. Ephemeral means it can the state is not maintained. So anytime pod can die down, and every time it can come again. So every pod will have an IP which is not reliable to rely on, because every time a new pod is created, it will have a new IP. So, but for outside world, IP is very important, because IP should be something unique. So for that, services play a major role. Services is nothing but a DNS endpoint, or a static IP. So just like a load balancer will have static IP, right? So you'll have a, for example, Google.com. Behind the scenes, there is a static, behind Google.com DNS, there is a static IP that is associated, and every time that IP will remain the same for Google.com. So that kind of unique IP is what is unique endpoint is what is exposed, and behind the scenes, this endpoint will talk to the respective pod IPs, which you need not know, or a end customer need not know that. So that is what is services. So in Kubernetes, services means endpoint. So of course, yeah, I think let's come back. Let's see this cluster creation. Yeah, I think it is done. So yeah, so now what it does is the cluster creation is done. So if you go back, it says, if you look at the basics of cluster, it says what is a cluster name and what is we create as journal type, and location is central one, US central one, and the version and the endpoint. So this is what this endpoint, which is static for this cluster. And if you look at the nodes, cluster, I said, like cluster will have 3 nodes. So to start with, of course, it's not mandatory to have 3 always. So by default, it creates 3 nodes. So if you look at node pool has node pool is nothing but a pool of nodes, and nodes are the individual nodes. For example, these are 3 nodes that are created. So if you look at each node is nothing but a VM, a virtual machine. So basically, it created 3 virtual machines, and also every virtual machine has a CPU, a memory, storage that is allocated. So for example, in this case, each one has around 400 CPU space that is allocated, and some memory space is also allocated for this. So basically, it's nothing but a virtual machine. So so basically, it also has a storage, because virtual machine, you create a virtual machine, it also comes with a storage, right? So by default here, a storage class is not associated, but you can also associate a storage if you want. And of course, logs is you can see the logs of the cluster that it created. So you can fetch all the cluster logs. If anything fails in this process, you can see the logs and troubleshoot what is the issue. So yeah, so at this point, what we create is a cluster with 3 nodes. I just want to show you that these nodes are nothing but virtual machines. So I'm just going out of Kubernetes, and I want to also, I'm going to the virtual machines, so that I can see. If you look at first, maybe look at the names, which they all start with GKE cluster 1. So GKE cluster 1 like this. So for example, OP6X is the name, for example. Let's see this name. I'm just going to virtual machines now, just to show you that virtual machine is what is created behind the scenes. This is compute engine is what is equivalent of virtual machines. So I'm going here. So VM instances. This is virtual machines. So if I go here, I can see those 3 virtual machines with the same name, GKE, OP6X. These are 3 virtual machines that were created. So basically, it's nothing but you created 3 virtual machines. When you create a cluster, it is nothing but it created 3 VMs, and it grouped them together and say this is cluster 1. That's all. That is what is done behind the scenes. So I'm just going back. Okay, so at this point you created a cluster. Now, your first thing is you need to link to the cluster. So you need to connect to the cluster. So for that, you can click this cluster, and you can say connect. This connect will fetch you a command line utility, and it will give you a command line gcloud container clusters, get credentials, cluster name, which is cluster 1 in our case, and zone is US Central 1A, and the project name is this Team Spider, whatever this name. So this project name is nothing but my every project will have a project ID. For example, my first project is the project ID. I could create multiple projects. I mean, in Google, everything starts with a project. You need to define what is a project. I think I took the default name is my project, my first project. But otherwise, you can create your own project also. But this ID is what is unique for every project. This is called project ID. So this project ID is what is used here. Yeah, this project is a project ID, Steam Spider. Okay, now let's, what I'm going to do is, I'm done with the UI part. I'm completely now going to a command line utility. So I'm copying this command. And this is just like any other Azure or AWS, there's a cloud shell that is available. You can click this and execute your commands in this cloud shell. So this will open a cloud shell for you. Just for sake of this, I'm opening in a new window so it's bigger. So here, every command, every operation that you're creating in UI, you can also do the same thing in a command line. So, and just especially for your automation of your projects in real time, you generally use more of command line in real time projects. So UI is difficult to navigate across, and automation aspect and all will be difficult. So yeah, so here I'm connected to Cloud Shell. So first thing is you need to set your project ID. So I'm just copying this. I need to set my project. Okay, so here it's asking to authorize, as I authorized it. So now basically it is asking permission from me. The Cloud Shell can execute the commands on your project. I said I gave the permission, authorize, and then it connected. So now you see my project ID is displayed. So whatever commands that I execute, now it will be applied to my project. So that's why this set project is important. So once you're setting this project, generally in real time we might have worked with in multiple projects. So first, that's why it's important to set what is the project that you're working. So I'm setting my project. Now with this, whatever command which I copied earlier. So I'm copying it. So what this does is this will tell me that I'm now whatever command that I execute going forward, they will be applied to all the nodes within the cluster. So for that I need to get the cluster credentials because every cluster will have credentials which you will not be able to see, which is hidden from you. So you need to get the credentials of the cluster. So that way, once you get the credentials, whatever commands that you execute going forward will be applied to all the clusters, all the nodes within the cluster. So if you look at the cluster, fetching cluster endpoint and auth data, and also it says kubeconfig entry generated for cluster 1. So now kubeconfig entry is created, so which means now I can talk to, in one command I can talk to multiple nodes at a time. So so now let's go back. I just created some simple command. Before that, I would just want to show you. I create a sample Hello World application, which is there here. I mean, this is simple Java application, which so this is. I mean, I'm not going to the Java world, but again, you just need to. You can invoke this Hello World endpoint. Once you invoke the Hello World endpoint, it will return Hello World, and it will give you what is the version. So that is what it does. So we're going to invoke this endpoint. It's a web application. I mean, the concept will remain the same whether it's Java, .NET, or Python. This is a sample Java application where if you invoke Hello World, localhost 8080, for example, whatever the domain name / Hello World, it will return you Hello World in the browser. So that is our simplest application. So this Java application, I already Dockerized it. So I have a Docker file. I think this is a sample Docker file using OpenJDK 8 Alpine. I exposed port 8080 and I created the. I mean, in Java, everything is binary is a jar file. So yeah, and then I'm executing this Java jar command. That's all. So this Docker file is already containerized, and I already hosted this in Docker Hub. This is what I'm going to deploy it now. I just want to show you the hub.docker.com. This image. I mean, this is what we saw in the last demo also. This is where it's a container repository. So I hosted this. I mean, I prepared this all in advance so that I will not waste time in creating this because we already saw this in the last demo. So I just created an image, a container image here, which I can call this image with this name. For example, Hello World REST API is the Docker image of this Hello World application, and followed by that, this is a release. 001 is the release. Why I'm showing 001 because soon I will deploy a 002 also. So that's why I'm first deploying the 001 release. So I go to Docker Hub. This is my user ID, and with this I already deployed this Hello World REST API here. So if you go here, you can see two releases, 001 and 002. First I'm going to deploy 001 and followed by that I will create 002. Yeah. So now, so basically this is the steps that we already did. We created in Google Cloud we created a cluster and with 3 nodes. At this point the nodes are empty. Nothing is deployed. So now what we're going to do is we're going to deploy this Hello World application there. So this kubectl is one popular one command line that you need to use for Kubernetes. If you remember, it's similar to Docker command that we used. More or less, whatever you learned in Docker, you can replace the Docker with kubectl. Most of them will be similar to Docker. So that's where like Kubernetes ensured that Docker commands are used as possible in Kubernetes. So just replace Docker with Kubernetes. Most of the things will more or less will remain the same. So here for Kubernetes, to talk to Kubernetes, you need to use the command line kubectl. So anything starts with kubectl will like create, kubectl expose, kubectl. So everything is kubectl. So now what I'm going to do is I'm going to create a deployment. And the deployment name is Hello World REST API. And for this that you want to use is my Docker Hub hosted 001 release tag image. So I'm going to deploy command. Done. So it says the deployment is created successfully. Next, what I'm going to do is I'm going to expose a service. Which of type load balancer? I want to give a load balancer to this, so that way when the load is more, so it is easier to manage. So and I want to give the port because it's a web application. I need to give a port. So the port is 8080. So I'm going to expose this deployment with load balancer of port 8080. Testing it. Done. So with this, now if I go to the service and ingress, I mean, I need to know what is my IP now to access this web application. So for that, to know the IP, I can go here. Where is this? Okay. So if I go to services and ingress, if I create a service now, so which is of type load balancer. Here it is creating a service endpoint. So I'm just refreshing it so that it says OK. It's still creating it. Yeah, now it came as OK. So which means a service endpoint is created, and this is my endpoint IP. So if I click this, this is where I can see my output of my application. Sorry. Okay, so this is my default, and I'm just going to give hello world. Super. So it printed my hello world v1. So this is what I show you in the code as well. So it prints the hello world message. Oops. This hello world v1, and after this, this is the machine name. Retrieve instance info instance is the node info. Basically, it's nothing but it prints the machine name. So just to show that from which machine it is coming from. So for example, this is the machine name of one of the nodes that we created now. So yeah, that's also that's simple. So if you look at we actually create a Docker image. I mean, for Kubernetes, everything starts with a Docker image. So that's a prerequisite. So I created a Docker image and already uploaded it to Docker Hub. I just ran two commands. One is to create the deployment, and one is to expose port 8080 onto this. That's all. These are two commands that I need, and my application is up and running. And it comes with a lot of features. I mean, which I will show you in the following screens. But so you can do many things. Whatever we saw as the features in the Kubernetes slides. I will see all these features now. So before going to the features, let's look at some of the basic commands. So we we discussed what is pod and all, right? So pod is something but a list of containers. So let's look at some of the pods. These are all get information. You can use the get commands to get the pod details, the deployments, service, and events and replica set. These are the things that we can see. Let's understand what are these. When I say it will get pods, at this point, it created a pod, and it says the status is running, and the time it took is 3 minutes. 3 minutes back, this was created. This is what is. So if you look at, there is only one instance at this point, one pod. Soon we will see the scaling part, or we'll scale this instances to 3 or 4 or to 6. You can create it. So it will create so many counts. So at this point, it created only one. So I just want to see that check the counts of the pod which is one, and also look at the deployment that we created. We're going to get deployments. This is again the deployment is nothing but the image where you uploaded this container. So we basically created that deployment image, and you can get the list of deployments using this command get deployments. In our case, it's only one, but typically if you're a microservices based application, when you see get deployments, you will see so many. If it's a microservice, so every service is one deployment, so you will see multiple deployments also here. And get service. This is where it will tell you this is a service is a networking piece. So this will give you the IP addresses. When you say networking, the port IPs, all managed by this service component. So here we created a type load balancer. That's why the type here is load balancer. And the cluster IP, you can forget about this, but this external IP is what is important. This is what we used to invoke the URL. This is the external endpoint. So this is what is unique for the external world. Behind the scenes, these pods can, as I said, like it can die down. Pods will also have an IP. Pods here. Pods can also have an IP. But those IPs are ephemeral. I mean, they can die down. Whenever a new pod is created, it comes with a new IP. But for outside world, we can't. We need a static IP, right? So for any DNS requirements, you need a static IP. So the static IP is what is provided by this service component, and it is and basically here, similar to what we learned in Docker, we are exposing 8080 as your outside port, but internally this is the internal port that it uses, because this is Kubernetes specific component which is not related to Hello World. This is something Kubernetes service also will be listed here under service. But yeah, but what we're interested in is the Hello World. So that is about service. and you can look at the events. So if you're interested, especially for debugging purposes, something goes down or something is not working, then you'll be interested to see what is the sequence of steps that it took. So if you look at here, these events will give you that information in terms of what are the steps that it took. It initially created a node. If you remember, we created a cluster with 3 nodes, right? So it is created 3 nodes, OP6X, 38Q1, and G1, B1. So BN, sorry. So these are 3 nodes that were created. So all these events were logged here. For every node, it just created an event every time a node is created. It created all the log, and then once it created a node, and then it created pods inside the nodes. Basically, your hello world image is your pod. So it created a pod inside each node. And also it created a replica set. We'll see what is replica set. I think we discussed it, but it will create a replicas. By default, we didn't give any replica requirement. By default, if you don't give anything, it by default is 1. It creates only 1 pod. But if you want to scale up, then you need to increase your replicas. So a replica set will ensure that the scalability aspect is covered. So in our case, it is only 1 pod. And next, it created a service. Like it gave a load balancer. So it gives a complete summary to you. So basically, with the 2 commands that you executed, you can see all the events. It created 3 nodes, OP6X, 38Q1, and G1BN. So all 3 nodes were created, and also it created your deployable unit, which is hello world image, creating all these 3 nodes. And also it created a replica set, which means it created only 1 pod, because since we didn't give any requirements to scale up, by default it took 1. And also it exposed the service, so that the load balancer, it has a unique IP, a networking component is associated. So you can access that with a URL. So yeah, this is something that you need to know. A lot of things are running in the background, so with just these 2 comments, many things happen behind the scenes. So and also you can see the replica set. Yeah, so replica sets will always ensure that the desired is matched with current. So current, I mean, in this case it's 1. So current will always match to the desired. So that is what replica sets will ensure. So you're telling that this is my desired state, my expected, my requirement, and this is the current requirement. So replica sets will ensure that these both match. For example, in this case, both are 1, but let's say, imagine this desired state is 3, which we will do it in the next command. When you say desired state is 3, like I want 3 instances of hello world, then the one replica set will see that the desired state is 3, then it will increase the current to 3, so that the desired and the current are matching. Okay, so yeah. Now let's see the same thing. So let's create the replicas to 3. Basically, I'm now scaling my requirement. I see a lot of load, and I'm increasing my the scale from 1 instance to 3 instances. Again, it's just 1 command. We already saw 2 commands. Now we are looking at the 3rd command. So the scale command, which is you're telling scale a deployment, and my deployment, the deployment name, and how many replicas I need. Replicas is equal to 3. So this will scale my instances to 3. I'll just clear the screen. So that's all. It replicated now. So if I look at the get pods, earlier we saw 1. Now we should see 3. Again, I'm using get pods. You see, now earlier it was 1, and now it is increased to 3. So again, get replica set. Earlier we saw it is 1. Now it will be 3. The desired state is 3, and current state is 3. So yeah, that's what the replica will be. This is a desired state saying this 3 is what my requirement is. Then replica sets will look at that and see that desired state is 3, and will increase the current state also to 3 to match the desired state. So So that's about the scaling part. Again, it is very simple. With one command, you replicated, you scaled it to 3 nodes. Let's say you want to we also discussed about the self-healing part, right? So we saw it one of the features where it can do self-healing. Okay, so self-healing is like if something goes down, if let's say a pod is down, so then automatically it should self-heal. You don't need to do anything. Kubernetes will ensure that a new instance is automatically created if something goes down, if some pod is down, it will automatically create and ensure that the desired state is met. So to see that feature, what we'll do is I will delete one of the pod. So in this pod, we saw this ID. So what I will do is kubectl delete pod ID. I'm deleting that 8H. Just remember this 8H name. You'll see this name will not be there again. Deleting this pod. This is deleted. So which means at this point I'm deleting the pod. So if I invoke this browser, so I mean if you look at still the instance is not down. I mean it's still working. I deleted one of the pod, but still the instance is working. Because if you see here the ID name is changed. Earlier it was a different name, but now it is changed. So this shows that your application now again it is changed. So again it is being load balanced. At the same time, one of the thing is down. It still ensures that the service is not down. So this is again self-healing. Again, if you look at ideally we should deleted one. When you do a get pods, actually we should see two. But because of self-healing feature, it will automatically increase the instances back to 3. Again, see that again you have 3. If you look at that 8H is not there because we deleted, but instead of that it created a new ones. So that is the beauty of this self-healing feature within Kubernetes. Even if something goes down to a pod, I deleted it manually, but it could happen that this pod, because of some resource constraints or something, your application is the node is having lesser resources. For some other reason, this pod got deleted, or it was not up. Then Kubernetes will ensure that the pod is deleted and a new pod is created instead of the old one. So again, that's the self-healing feature of Kubernetes. And this is very, very important because otherwise, as an operation person, if something is down, then you need to figure out what to do to bring the new instance. But with Kubernetes, it is taken care automatically. Okay, so let's move on.
Shyam, sorry, just a quick question.
Yes.
What happens to the process when a node is getting created or deleted? What happens to the process that would have been running on that particular node? What will happen to the status? Will it get saved before the machine is deleted, or how is it? Any insight on the internal architecture of how it's being done? Will it be covered in the later? Then probably I will reserve my question.
Yeah, it will be covered in the later, but I will tell you what happens. So it will everything in a node, whatever the node, whatever is running, the state is maintained in master. So master will know the status of all the states, all the processes that are running inside node. So that is the job of the master to ensure that a state of any node is maintained known at any given time. So once you see the architecture how this works, then you will understand that. But I think to answer your question in simple terms, yes, it knows the state. It maintains the state.
Excellent. That answers the question for now. Thanks, Shyam. And I will wait for more details when you cover it up later. Thanks. I get it. Thanks. Bye.
Just to give back, master maintains a database called etcd or etcd. So it stores all the state of your nodes inside that database. So basically Kubernetes knows the state at any given time, what is the state of a node, and it can replicate with similar settings. Yeah.
And it maintains the internal details of it so that some other node can take over this node even if it is deleted. So that much amount of detail is monitored by the master node.
Exactly. Yeah.
So, Sham, what you're saying is right. Like etcd means the state is correct, but I think the question was internal state of that container, right? Pod is nothing but a container, right? Like it is. So in this kind of architecture, I think it is a microservice. Usually, microservice is a stateless machine, right? Like basically, it's just getting a service request, it's processing it, and then that's it. So that is the best in this kind of architecture in the Kubernetes. You don't maintain any state within the application. So let's consider the pod, right? The one instance that is running. It's an application. You don't maintain any state inside that. That should be the ideal architecture. I don't
Yeah.
know how you will follow that, but I think that's what Bala asked actually, right? What happens to the inside of that container?
So
I
inside
don't
of the
think we don't keep
container,
that.
yeah.
We don't keep that state. So
Yes, that was the question. And Shyam said that the internal details would be monitored, and at any point in time, before it is getting deleted, the status will be known to the master so that some other new node can take it over. So at this
No,
point in time, that answer was satisfactory for me. So I will wait.
yeah.
I said I will wait for. Thanks for that
So can
insight,
you guys hear
Gnanish.
me?
Srini, yes, we are able to hear you. Please continue.
Yeah. So the thing is, the question is, if you have a stateful application, then you have to have something called stateful set and so on. So to answer your question, there are two different things. Maintaining the node is a different story, but persisting your application state is a different story. Persisting your application state, you have to design through a stateful replica, stateful set.
Stateful set.
Okay. Yeah. So that is a different story. And those are all, see, the problem with all these, right? So the more you go deep dive, it's going to go little peeling onions thing. Yeah. So we can go little deep dive, but you have to introduce concept one at a time. There are so
Yeah.
many concepts inside.
Yeah. I think
Agreed.
see the
Agreed.
yeah, we'll cover that going forward. I think the state Kubernetes, as Jani said, Kubernetes is initially started with a stateless service, but over a period of time, state has to be stored somewhere, right? So it is not possible to have a stateless service for all. So the recent additions in Kubernetes were completely rewritten to persist the state also. That's where the stateful set, I think we will come to that later. The stateful set, persistent volumes, these are all things which are, for example, database. If you have database, then the database per state has to be maintained. So the state was a recent addition to Kubernetes. So it is I will come to that. It's also some advanced things. We will come to that later. But for now, the answer is it will know the state. Okay, so yeah, so let's go further. I think we are running short of time, so I think we'll logically close it. So we looked at the state. So far, we increased the replicas, and we saw that the counts were increased. And now let's quickly. I think we deleted that as well. So, yeah. So now what I will do is I will imagine a scenario like this. So, you have a requirement where at any given time, this is an again common operations problem that operations team has to maintain this. Where application is so popular, it becomes so popular, and you see that during the day there is a lot of load to your application. Again, you don't want to manually increase or decrease the instances. So how will you maintain such requirements? Like you have to, the load is more in the morning, but not in the evening. So in that case, again, it's just one line command for that. You can auto scale based on CPU percentage, and you can tell what is your max number of instances. So this will solve most of your 90% of your scaling problems. Then what I'm doing is I'm auto scaling on a conditional basis. So far we saw replicas is 3, yes, that is scaled up just the instance. But I don't want to increase the replicas to 10 or 100. I want to do it based on the load on my node. I want to conditionally auto scale. So if that is the case, that is also solved with just again command line, one simple command line. Here you're telling max instances is 10. So basically, I scale up from 3 to 10 based on the load. Max is 10, and the condition should be CPU percentage on any given node is reached a clocked 70%. then you increase that instance from 3 to 4 or 4 to 5 likewise. So that is so this serves most of your conditional load requirements. So again, this is, I mean, the thing that I could show here as a demo here, but yeah, this is one command that you can simply execute and it is auto scaled. Where, I mean, if your CPU is spiked up, then automatically the 3 will become 4 and 5 and like this. So that is about, that covers the CPU load part, conditional increase or scale. Then the next scenario is, again, I have a new release coming. Then I want to make a new release without anything going down. So again, that is also one of the features that we discussed, right? So automatic rollouts and rollbacks. So from the requirement is now I want to move from production 001 release to 002 release. So this is my requirement. So it is simple. Again, I'm just setting my, just for the demo purposes, I'm just setting the minimum ready seconds to 15 so that you see that I will, when I replicate it, I will have some time to show you that it is really replicated. So I'm just going into edit deployment and making the min ready seconds to 15 seconds. This opens, this is a YAML file which I was referring. So this is, behind the scenes, this is what is created. So I'm manually going and increasing the, I'm going insert mode. I've just added this command, seconds. Saving it, I came back. So now my, I just edited my min ready seconds. I will tell you what is that min ready seconds. And now I'm increasing my 001 to 002. So before that, I just want to show you that this V1 is what is there. Once I deploy my V2, this will become V2. So I'm just refreshing it in V1 still. Now I'm deploying my V2 release, 002 release. Again, the command is set image deployment, my existing deployment name. I'm asking to change this deployment name to a new image. Again, which is also there in Docker Hub, which we saw. So again, we already saw it, right? So yeah, so it is there in Docker Hub. Yeah, yeah. So 002 release is already uploaded. I uploaded this image already just to save time. So I'm uploading this 002 here. And only change is that V1 will become V2. That is only difference compared to V1 and V2. I'm just refreshing it. Open, just saving the state, I guess. Open incognito mode. Okay, it changed to V2. So if you look at here, V1 become V2. So refresh here also. Become V2. So yeah. Now it is just one line command. Again, I changed my version from V1 to V2. So which we saw that. And the last one, let's say there is some issue in your V2 release and you want to go back or roll back to V1. So again, same command, instead of V1 002, I'm bringing the 001 back. Again, I want to downgrade my rollout. That's all. So it is updated. So it will be updated very soon. It'll take a couple of minutes, but for seconds, but I think it will be back. We'll let that go on. So, but yeah, otherwise, these are some of the delete commands that you can use. Delete, if you, let's say you want to delete all your deployments, you can delete this. You can delete all deployments, delete all pods, delete all service. You can use all these things. So, Yeah, I think let's go to the. Probably, I think we'll logically close it here. But yeah, P1 is back. Okay. So yeah, I think logically we'll stop here. But I wanted to you get a features more or less all the features that we saw here we already covered. At least not all, but some of them we already covered. Auto scaling we saw. We did not see in the discovery, but load balancing we saw, self healing we saw, rollbacks and rollouts and rollbacks we saw. These are some advanced features which will cover for a bit of time. But yeah, you got some basic idea now how again it's all our kubectl commands. So that as a developer you just need to know these commands, how to deploy it, how to expose a load balancer, and how to get the statuses at any given time, and how to scale, how to increase the replicas, uh, delete and also auto scale based on some conditional requirements. And how will you do auto rollout and rollback requirements. These are the common day-to-day operations that we generally do in deployment, right? So we deploy, download, upgrade, downgrade, increase instances, so conditional scaling aspects. These are things, the common things that we generally do in day-to-day life. These are all covered with just one command lines. So yeah, that's the power of Kubernetes. Yeah, with that, I think we'll logically stop here. So
Yeah. So only one point is if you have on-premise or across cloud, same command. That is the beauty. You don't have to learn different things. That is why people are going for.
Exactly.
Yeah. Thanks, Sam. Yeah.
Thanks, everyone.
Thanks.
Thanks, Shyam.
Yeah,
Thanks
bye
very
bye.
much. Thanks, both.
You.
Thank you.
Thanks.
Thanks, Sam.